Test, testing. All right, good. Sierra. All right. So uh, when I look at the exam, I have a bunch of different topics, and you see those topics on the quizzes. Like your quizzes cover all the topics that will be on the exam. We still have one topic that we haven't covered, and that's vectors. But I'm going to tell y'all pretty closely what to expect for that. All right. So in chapter 1, we had things like unit conversion. That's one of the topics. We had estimates in order of magnitudes. You need to know what a meter is, what a centimeter is. You need to know what a kilogram is. You need to be able to estimate things like common things that you know. We also had dimensional analysis. There are two problems like that. There's one where I give you some equations and I ask you if they're dimensionally correct or not. And then there's another where I give you an equation and I ask you what must the units of this variable be in order for this to be dimensionally correct. I'll show you some samples like that. We did some in the various quizzes that we had. Dimensional analysis, see there are 6. What were the others? Sig figs. Standards. You need to know what all the standards are. There'll just be a basic question that says, what is the standard for time? What is the standard for length? What is the standard for mass? You need to know that. Don't forget the standard for mass. It will be that silicon sphere, but right now it's just a cylinder, right? Remember the video we watched on the silicon sphere? Even the online spheres, I think y'all had that. But the answer to what is the standard for mass is that cylinder in France. All right, so that's chapter 1. Gosh, it feels like I'm missing something. I'm missing a topic. Let me just skim it right quick. Unit conversions, sig figs, trig, right. So then there will be some basic right angle trigonometry. You'll have that for the vectors too, but I'll give you a triangle and I'll ask you what is this side, what is this angle, what is this side, what is the hypotenuse, all right? So that's chapter 1. Chapter 2, I basically break this down into conceptual problems and calculation problems. And we'll work through some calculations today, and we're getting to that in chapter 2 right now as well for looking at kinematics problems and calculating various things. And really, that's all about knowing those two equations, right? That V equals V naught plus AT, which we just got to in the in-class section. You online students, you may have gotten this yet or not, depending on how far along you are. And then also this X equals V naught T plus 1/2 AT squared. It's really just knowing what those variables are, reading a question, and figuring out, well, what is this thing, what is that thing, and then putting in the right equation. All right, once you get the hang of that, like if you haven't done that before, it's kind of difficult, but after a few times, it gets a little easier. And then the third chapter, which we haven't gotten to yet, but we'll spend a couple days on it next week, Monday and Wednesday, and that is vectors. And you're going to have basically conceptual, adding up vectors, and calculations. These aren't that difficult. The calculations are really just trig, finding the x and the y components of a vector. In short, just to give you a little preview, a vector, if we have two vectors, say I have a vector here, we represent it with an arrow. The length of the vector represents the magnitude. The direction of the arrow represents the direction. So like for example, this would be x units, say it's 2 units long along the positive x-axis. This would be the y component of a vector, and then we have a resultant of the vector. So that's where that trig comes in. I'm going to show y'all very clearly. I'll send y'all an email about sort of what to expect because we're sort of squeezing in these vectors, but you'll have 4 questions, and I'll be very clear with you what to expect on the test for those 4 questions. Okay? I want everything to be very clear what to expect. Okay? Unit conversions that somebody asked, so I'll give you a little primer and then we'll see it in some sample test questions. But let's say, for example, I want you to convert, I don't know, 54 kilometers per hour, which you could have to do, into meters per second. All right. You need to know your conversion factors, and then you need to know how to work with these units. So the first thing I want to do is convert my hours to seconds. And gosh, what would I put in the numerator here? Hours or seconds? I would put hours, right? Yeah, because I want those to cancel out. And I know that in 1 hour, how many seconds are in an hour? Right, there are 3,600 seconds. You're going to have to do this conversion on the test, by the way. It's embedded within a problem, but make sure you can do it quickly. And then in a kilometer, how many meters in a kilometer? No, that's meters in a mile. Okay, I'll give you any funky conversion factors like that, but I'm not going to give you your metric conversion factor. So you need to know these. In 1 kilometer, 10 to the third, or 1,000 meters. Remember, you need to know nano, micro, milli, uh, centi, then it crosses over into the big kilo, mega, and giga. But honestly, the only ones that we've used so far are maybe these and these. So in practice, like actually, those are really the only three that you need to know right now. I don't even remember if milli is on there, but it could be. I don't recall. Huh? All right, the quizzes are different from the exam. I'm talking about the exam, okay? Yeah, so milli is 10 to the minus 3, centi is 10 to the minus 2, and kilo is 10 to the third. Okay, so make sure you know those conversion factors. If I do this conversion, I don't know, I get whatever it is, 54,000 divided by 3,600, whatever that happens to be. Okay? Make sure you also know, because you will have one of these, this will be an explicit problem, like a whole separate problem, how to do powers. Can I go down from here, y'all? Listen, guys, if I'm going too fast, I want to cover as much as we can, but if I'm going too fast, please just stop me. We'll have another help session next week, so we'll be able to do some other things right before the test and do more sort of a, you'll be better prepared for the help session and we'll be able to answer more specific questions. But make sure that you know how to do these power conversions. Let's say that I want to convert, I don't know, 35 meters per second squared, and I want to convert that into miles per hour. I think you had to do this in your homework or somewhere on the quiz, maybe some of you. By the way, if you notice, the quizzes, they change each time you do it, so y'all might not get the same quizzes. Um, so here you need to know your conversion factors. I will provide you with this conversion factor to the British system. 1 mile is 1609 meters, but obviously, I already know, many of you know that. So 35 meters per second squared. In 1 mile, I get 1609 meters. But, oh, what do I have to do that conversion factor? I have to square that one? No, I don't do anything to it. I just put parentheses around it. Okay. And then I have in 1 hour, 3,600 seconds. What do I have to do here? Put parentheses around it? Is that all? I square this one right, yeah. So that cancels out these seconds, and I'm left with miles per hour squared. And then you just multiply 35 times 3,600 divided by 1609. You will have one explicit problem, and then there's a unit conversion embedded within a problem. I point it out, and just so you don't forget to do that unit conversion. Okay? Those should be some gimme problems. Those are pretty straightforward. You know what? Honestly, they're all gimme problems. Like if you know sort of, if you've been well prepared, you should be able to make 100%. Right? 100% is not out of reach for you. I always have students make 100%, so it's certainly within reach. I almost always have students make 100%. Okay, did I start this? Yes. Any particular topics up here that I've written down? Don't worry about the vectors, we'll get to that. If we have time at the end, we can do that. Haley? For the calculations? Okay. Let's look at some sample problems from the test, because it's really just reading the problem and picking out what you know, and then looking at those equations and seeing what you don't know, seeing what you're looking for. Let's go ahead and pull up some. Uh, these are just old exams. So I'm going to pull up first exam 1 from last year. And we'll look for some kinematics problems. Look, I don't reuse questions. Every once in a while I reuse a question, but not usually. So you'll have new questions, but they're a lot like these questions. So a good place to study here is on these old exams. Sorry, I was thinking. No, it's a mix of all. I mean, if you look at these, you'll see that there are, you know, questions that you should know the answer to within 10 seconds, and then questions that will take you a couple minutes to sit down and work out several steps. I try not to have too many steps on the questions, like calculations, because then, you know, it's just more prone to mistakes. But I try to make them simple as possible. Andre? 28 questions. Yeah. So yeah, you'll get a little bit longer than you'll get an hour. Okay, so that's you know, some of the questions you should know, boom, 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 but others are going to take you a few minutes. When I work it, I do it in just under 20 minutes. But you know, I wrote it, so I know exactly. What's up? In the auditorium, yeah, an Pouch auditorium, so you'll be nice and comfortable. It'll be cold probably, but bring a jacket. Freezing, you'll freeze your bottoms off. Um, let's look at kinematics. You will have graphing problems. Ooh, I didn't mention that. Let me go back. You will have graphing. You will have graphs. Qualitative. Right, that means look at the shape of this graph and describe the motion. We went over that in class. You online students, you had a whole little extra video on a whole bunch of that stuff, and I'm going to send that video out to you in-class students to see as well because I think it'll be useful. And we did it in class as well. And then you also have graphs quantitative. That just means you pull the numbers off and you calculate things like instantaneous velocity and acceleration. You calculate distance traveled. You calculate average velocity or acceleration. We'll see those, but let's do some of these kinematics problems first. Okay, so right, number 15 here. This one's pretty straightforward. You have to be careful with your signs here, but as I'm reading the problem, I just want to write down everything that I know. This isn't generally true for all questions that you'll have in any class. It's just write down what you know. And you know what? I also like to write my equations off to the side. Or you'll have these special forms that you'll use. You can write those equations on that form. That way you always have them in front of you. You only have two equations that you need to know, these two kinematics equations. Well, and then the trig and area and volume and stuff like that. There are no funky volumes, just like cubes and squares and stuff like that. But these kinematics equations are x equals v naught t plus 1/2 at squared. And then v is equal to v naught plus at. So you should already have like a note card attached to your bathroom mirror so you see these every day for the next week. Y'all did that, right? Yeah, it's a good idea. If you don't know them right off the top of your head, you should know them soon. You need to know what these variables mean. This is the initial velocity. This is the acceleration. This is the time at a particular instant, okay? This is the position, initial velocity, the time, acceleration, and then this is the position, the x position. So here, it's traveling at 20 meters per second. It slows down at that rate. How far does it travel? So what does the 20 meters per second represent? Not just the velocity, but the what? The initial velocity. Because that's what it is at time equals 0. That's our state before it starts changing. So our v naught is equal to 20 meters per second. And what is the 10 meters per second squared? Units are your friend here, okay? So I have meters per second squared. It's going to be acceleration. And if somebody corrects me, I will consider them my friend forever. It should be negative. Thank you. Very good, Sarah. Sarah. Yeah. But Brooke, you were about to say the same, weren't you? Okay. Okay. All right. Acceleration is negative. Listen, you have to read these carefully because it says it slows down at a rate of 10 meters per second squared. And since the velocity is positive, if it's slowing down, the acceleration is opposite the velocity. So in this case, negative acceleration does mean deceleration. and then how far I'm looking for x. Does it travel in t equal 2 seconds? All right, so I want to find x. That's easy because the only equation is this one that has x in it. So I say x is equal to v naught t plus 1/2 a t squared. And then I can find out, I just plug in the right numbers. I'll say 20 meters per second times t, which is 2 seconds, plus 1/2, making sure I get that sign right, minus 10 times 2 seconds, and I square that. So that's 40 minus 5 times 4, which is 20, so it's going to be 20 meters. Yeah, Kaylee? No. Yeah, let's look. So it says that it slows down at a rate of 10 meters per second squared. It's the slowing down that tells you that it's negative. Remember we talked about this, that if the velocity and the acceleration are in opposite directions, it's slowing down. If they're in the same direction, it's speeding up. So if it says that it speeds up at a rate of 10 meters per second squared, then that would be a positive 10 meters per second squared. Okay, that's a pretty simple kinematics problem. It could be that you have a, yeah, Ria? Yeah, we'll look and see. Like the graphs, where it shows you the graphs? Okay, I think I know what you're saying. Uh, like where I show you the graph and I ask, is the velocity increasing or decreasing? Okay. While we're on the kinematics problems, we're going to get to that. But let's go ahead and see. I want to see if I can find a two-step problem. Because this one's pretty straightforward. You just write down everything that you know. You just plug in the right numbers. One step. But you can envision that maybe you didn't have everything. Like say, for example, here, if I didn't have t equal 2 seconds, then I couldn't solve this equation. So you can have problems where you don't have all the information that you need, and you have to do a substitution, or you have to solve one equation to get one value to plug into another equation to get another value. You are not going to have to solve a system of two equations. You did have to do that in your homework, okay? But you're not going to have to do it on the test. A system of two equations means that I take one equation and I solve it for one variable, and then I plug that equation into a second equation. Y'all did it in the homework, but you're not going to do it on the exam. Likewise, I don't remember if this was in the homework, but you will not have to use the quadratic formula, okay? Half the time, I don't even get the quadratic formula correct. Like, I get the wrong answer, I'm like, well, that's not right, and I have to go back. So, I don't know, something about those A's, B's, and C's gets me all mixed up. So, it takes too long, too, so you're not going to have to do that. But you could have a two-step problem. Can I clear this out? Okay, let's see if there's one here. Ria, this is what you were talking about? Yeah, we'll come back to that, okay? That's important because you will see stuff like that. Um, this is it. Number 21. Let's look at this one. This one's a little trickier, a little more difficult. Um, a truck covers 100 meters in 10 seconds while smoothly slowing down to a stop. So it covers x equals 100 meters in a time of t equals 10 seconds. All right, what was its initial velocity? Oh, I'm sorry. No, no, no. I want to know what its initial velocity is. What else do I know here? Anything else that I can find out from this? Okay, it's slowing down, so I know that my acceleration is going to be negative. I'll just write that off to the side because it's slowing down. What else do I know? It's stated in words, but not in numbers. The final velocity is 0. That's right, Kaylee. So the final velocity is 0. All right. And now I want to know the initial velocity. I'm going to write my equations over here. X is equal to v naught t plus 1/2 a t squared, and v is equal to v naught plus at. And then I want to ask myself, how can I get that v naught? So if I look at both of these equations, let's see, I know V here, I don't know V naught, and I don't know A. So I cannot solve this, right? I know X, right? I don't know V naught, and I don't know A. Oh, this is a substitution problem. Let's go ahead and work it out, though. All right, so the way you would work this is you would say, no, let's not do this. I don't want to confuse you. Is that okay? Can we stop there? Right. You aren't going to have any type of substitution. Right. You could have. I could have put it on there, but I didn't. Right, because it stops. Yeah, so I mean just figuring out these variables is useful. I'm sorry. Just wasted 4 minutes of your life. No, but it is useful to read the problem and figure out those things. But don't worry about the substitution. Can I clear this out, y'all? See if I can find one then. I probably don't have one. I will come back to it, okay? I'll look on the other test, but let's look at these qualitative, what is that? Right. Let's look at this. I think Rhea asked about this. This kind of question. You will have one. It's going to look the same as this question. I'm going to give you a plot of position versus time. It may or may not look like this. And then I'll give you a bunch of plots of velocity versus time, and I'll ask you which one is the same situation. So this graph represents an object moving. One of these graphs represents that same object moving, but it's showing velocity instead of acceleration. This is number 16. So the first thing you want to ask yourself what the slope is doing, because the slope of a position versus time graph gives the velocity. So each point on here, the slope is represented by the value of this plot. So what is the slope doing here? Is it increasing, decreasing, positive, negative? What's the slope doing? It's decreasing. It's big, and then it gets smaller, steep, less steep. So it's decreasing, and then is it positive or negative? Positive. So I have a positive slope that is decreasing. Now just the fact that it's positive gets rid of two answers. Which are those? All right, I get rid of these. And then the fact that it's decreasing tells me that the answer is C. All right? Does that help a little bit, Rhea? You want to ask, what is the slope doing? You're going to have some quantitative graphs too, where I show you, like this one right here, I have a velocity versus time graph. In a velocity versus time graph, the slope gives the what? Acceleration, right. If you ever forget, you can think about the units. Slope is rise over run. That's meters per second over seconds. That's meters per second squared. So that's the same units as, acceleration. So finding the slope is the acceleration. What does the area under a v versus t graph give you? The area. The distance covered, right. And if you forget that, you can think about the units. The area is base times height. That would be meters per second times seconds. And so that has units of meters because the seconds cancel out. All right, so this 19 and 20 use both of those, and you'll see similar problems on the test, but, different graph and stuff, of course. Here I want to find the acceleration at t equal 4 seconds. So I draw a tangent line to the function at t equal 4 seconds. Looks something like that, maybe. And then I just find the rise over the run. Now look, first of all, I know this has a positive or a negative slope. Negative, so I can get rid of A and C. And then I just do rise over run, being very careful not to do what? Do not count the squares, all right? Because if you look here, we go from 2 to 4. So on the y-axis, the square is 2 units, but on the x-axis, it's just 1 unit. So my rise goes from 2 to 10. So I have a rise of 8. I have a run of 2. So it should be -4. But you know what? Your tangent line is sort of subject. So back when I wrote this, I drew the tangent line differently. So I just take the closest thing, which is going to be -5. And you might envision a slightly different tangent line. Like, let me show you. I could have drawn the tangent line maybe like that. Yeah, that must have been what I did. And then my rise would be 10, not 8. The tangent line is, you can think of it as a line that balances on the function. I always like to think of it as like a seesaw on a hill. So like if I have a hill like this, uh, if I put a board right there, that board is tangent to the hill. Or if I draw a line over here, it looks like that. Over here, it looks like that. There is a mathematical definition, but it has to do with sort of distances between the line and the function. But just, you follow how to draw that intuitively? Y'all okay with that? Listen, on this one, when I gave this, these numbers are a little close for me. I mean, somebody might draw their tangent line wildly off and get -2. But on the exam, I'll make sure they're very different. So it'll be clear what the right answer is. You might not get exactly the same as what I put down there, but you'll get awfully darn close. And then number 20 asks for what is the total distance traveled between 2 and 5 seconds. Gosh, how in the heck do I do that? The distance traveled between 2 and 5 seconds. What do I find? I find the area. So the way I do this is I ask myself, how much does each block count? Each block counts for 2 meters because it's 2 times 1, and then I just count the blocks. So that's 1 block, 2 blocks, 3 blocks, 4 blocks, 5 blocks, 6, 7, 8. I'm going to call this one 9. With this one, I'll add those two together. I'll call this one 10. With this one, I'll call this 11-ish. It's about 12-ish blocks-ish. Let's see what the answer is. Yeah, see, it's 12. 12 is the right answer. Okay? Just calculating the area, and again, the answer will be distinct enough from the other answers that you'll be able to tell what the correct answer is. Oh, the block is equal to base times height. So the base here is 1 unit, and the height here is 2 units, 0 to 2. Oh, wait, no, I'm sorry. What was the answer is not 13, it's what? 12 or 13, yes, 24. Now be careful. So I made a mistake there. The answer should be 23, actually. B. Erase that. Because each block represents 2 units. Well, 8 and 2 is 4, right? But I just drew a different tangent line than the one that I did when I created this graph. So there's some judgment call, Houston, right, in the tangent line. But I'll make sure that it's clear enough, distinct enough from the other answers, the wrong answers, so that you'll know. So if you get, say, between -4 and -6, you should be able to pick out the right answer. Okay? Let's see. You okay on this? You'll see this next Friday. I clear this out? All right. Let's go back and look at those topics. So we've looked at graphs, qualitative, quantitative, looked at some calculations. I'll pull up another test. What about any of these other things over here? Sure. Let me show you the way I do it. I think that way is superior. All right. I just think it's easy the way that I do it. All right, let's do this one. You could have one like this, or you're definitely gonna have equations, and I ask you, well, I've already told you, right? Have equations, and I ask you to pick out the ones that are dimensionally correct, and then you're gonna have one with an unknown unit. Not like this, but this is still useful. I start with the first variable. V is meters per second. And then I go through and I write each variable. M is kilograms, X is meters, and then A is in the denominator. So I'm going to write it as 1 over a. Over here to the side, I'm going to write 1 over meters per second squared. But look, this is equivalent to seconds squared over meters. So when I write it, I'm going to write it as seconds squared over meter. And by writing it out this way, instead of writing it like this, it's just a lot easier to see what cancels out, I think. Maybe that's not you, but it's a lot easier for me. So my m's cancel, one of my seconds cancel, and I'm left with meter, kilogram, seconds, just D. So whenever I have something in the denominator, I just flip the units and bring it up into the numerator. Okay? Tell me your name again. Lindsay, right. Okay? Is that okay? Taylor? Is that a question? Okay, well, be careful because m here is mass, but x is meters. So mass is in kilograms, x is in meters. All right, be careful of that. You will have some m's. I get them confused too, right? The m refers to mass when it's a variable. The m when it's a unit refers to meters. Somebody have their hand up over here? No? All right, let's do one of those others because those are a little more complicated. One of those where you have, did I have one of those here? Yeah, let's do a different one then. We'll come back and do number 2, but you're going to have one of these, and I think these are a little more difficult. Let's say that I have x over v is equal to b, that's just some constant. Let's see v x over a. All right, I want to know what are the units of b to make this dimensionally correct. What are the units of b to make this dimensionally correct? And what you're going to do is just put in the units like you did before. So I have x is meters, v is seconds over meters, because, right, it's in the denominator, so I flip it. Those m's cancel. b is some units we don't know yet. v is meters per second. X is meters, and a is seconds squared over meters. And then I can cancel some of these out. I'm sorry, my x there should be in meters. This cancels with one of those. Oh, and this canceled with that. So I have seconds equals something times meter seconds. What must the units of b be to make this dimensionally correct? What is it? Not meters, but what? 1 over meters, because you want to get rid of those meters. So my b has units of 1 over m. So it cancels out that and makes it dimensionally correct. So the units of this are 1 over meters. You will have one of those, and we've seen some of those in the various quizzes that we've had. Uh, Likewise, you'll have one of those where I give you a set of equations. You want to look at that problem here, Andre? What's up? I did. The units for A are meters per second squared. All right. Which ones? Right here? Oh no, these would be multiplied, right? So it'd make meters squared. You only cancel out when it's in above one over the other. All right. Okay, can I clear this? I don't think I've ever had this many students at a help session. Like just at a non-week before or non-day before the test help session. You know why? Right? Like that I've had in years past. And last year, man, that's some good students. Um, okay. Andre, did you have a question? Rough about what? Dimensional analysis? Okay. Yeah, I erased it. I'm sorry. Now let me show you because Yeah, go ahead and tell them. Okay. All right, let's look at this one. And if we want, we can come back to that because it is kind of difficult to do that. All right, so which of these equations is dimensionally correct? Look, I already know that this one's dimensionally correct, right? Because that's one of our kinematics equations. So I'm not even going to bother with that one. If you get some some really complicated ones like this, I recommend that you simplify them before you start trying to put in the units. So notice here, I can just go ahead and get rid of the two m's. They cancel out. I just divide both sides by m. I can likewise get rid of one of these x's, and I can get rid of one of these v's, just leaving v squared over here. And that makes it a lot simpler. I get meters per second squared on this side equals meters squared per second squared times 1 over x, or 1 over meters. So is that dimensionally correct? It is, right, because this meters cancels out with that one. Give me meters per second squared. And then let's look at this last one. I have mv. I can go and get rid of these meters on both sides. Remember, I don't worry about the constants. Those don't have units. So I have meters per second. Meters per second squared, that's a. 1 over meters. Are those dimensionally correct? No, they are not. So it's only 1 and 2. B is the right answer. Get used to these kind of questions. You're going to see them all semester. I mean, where I give you several options, and then you have to pick some combination of those options. Students hate these, right? But they're good questions. They make it a little more difficult. Let me show you an example. So let's say that I had an equation that looked like this. X over v equals, or do ax over v is equal to vx a over, well, no, that's not going to work, right? No, I'm sorry. Is equal to, oh, shoot, I'm sorry. No, let's go back over here. Let me just, so what you want to do, if they're if they're on opposite sides of the equation, they have to either be both in the top or both in the bottom. That's different, right, when they're on the same side of the equation, because it's like you're dividing through the whole equation. Like I can divide through both sides of the equation, and that gets rid of these m's. All right. So if they're on opposite sides of the equation, they either need to be both in the numerator or both in the denominator for them to cancel out. If they're on the same side of the equation, they have to be in numerator and denominator. Okay, let me just show you. So if I have this expression, mx over m, right, these two cancel out, right? But if I have mx equal mx, these two cancel out. The x's cancel out too. So if they're on opposite side of the equation, they have to either be both in the numerator or both in the denominator for to cancel out. If they're on the same side of the equation in just an expression, they have to be one on top of the other to divide out. Because m over m is equal to 1. That's what happens to it, right? Any number over itself is equal to 1. Okay? Let's see, what else? I'm going to cut us off at about 3:45, 3:50. So we have about 5 to 10 minutes left. So what sig figs, dimensional analysis, estimates. Trig, you want to do a little bit of trig? Okay, you're going to have, I think you had 2 explicit trig questions, but then it comes up again in vectors, which we'll get to next week. So 2 explicit trig questions. It's just right angle trigonometry, but you know, it might have been a long time since you've had that. Yeah, we're going to have to do both, Victoria, so make sure that you're be up on it. If you need help, I can help you. All right, so if y'all are having trouble with the trig stuff, I've shown you everything that we're going to do. It's just the SOHCAHTOA and the Pythagorean theorem, but you will have to do both of those. So you'll have a triangle. You'll have either one side and an angle or two sides given, and then I'll ask you to find other information, either an angle or a side. So for example here, if I want to know the angle theta, I need to recognize that I have the adjacent side given, and I have the hypotenuse given. And then that'll tell me which do I use. Right. So SOHCAHTOA. Right. I have the adjacent and the hypotenuse. So I'm going to use the cosine. So I say that the cosine of the angle theta is equal to adjacent over hypotenuse. That's 5 over 7. And then I take the inverse cosine of both sides. And it gives me the angle. What is that? 44. Hey guys, listen. Oh my gosh, 44. Um, I often go through and I ask myself, what are some common mistakes that students make on this question, on every question? And then I put those answers. All right, so just because you get an answer that's on the test, that does not mean that it's correct. So for example, probably on this one, I did the inverse sine of 5 over 7. And if I do the inverse sine, that's 46 degrees. Yeah, so see, that would be A. A second, let me just finish, or let me just say that. So often I give the wrong answers of common mistakes. So for example, the answer here was the inverse cosine of 5 over 7, which is 44 degrees. If you can't get that in your calculator, just see me afterwards. I'll help you. But if you do the inverse sine of 5 over 7, that would be incorrect. You'll get 46 degrees. But you get 46 degrees. I don't know about y'all, but I get an answer. I'm like, well, that must be right, right? But it's not right. So make sure that you're very careful in how you look at it. Lindsay? Yeah, what's up? Okay. The inverse cosine gets rid of the cosine. So if I say the cosine of theta equals 5 over 7, you know, whenever we're solving an equation, whatever we do to one side, we have to do to the other. It's as if we're saying the inverse cosine of this side and the inverse cosine of this side. And this gets rid of that. So theta is the inverse cosine of 5 over 7. So the answer to your question is that if you're looking for the angle theta, you're going to have to use the inverse of the trig function, the inverse cosine, sine, or tangent. Well, say for example, I had a triangle. I'll just use the one that we did. I know that this angle is 44 degrees and that this is 5 meters. And I ask you, what is the hypotenuse? Then I would say the cosine of 44 degrees is equal to 5 over the hypotenuse. And then I would solve that for h, the hypotenuse. Solving it, I would cross multiply, or however you want to do this. And I would say 5, or that's not the best way. I'll just say h is equal to 5 over cosine of 44. And then that would be equal to 7. That'll be really important for your vectors, because we're going to look at vectors next week, and you'll have to do that sort of thing. Right, so you have two trig questions. I'll show you a picture of the triangle, and I'll ask you to find one of the sides or the angle, or yeah, one of the sides or the angle. You have to either use the Pythagorean theorem or these trig functions. Remember, the Pythagorean theorem, of course, describes the relationship between these three quantities. It would be 5 squared plus x squared equals 7 squared. The two sides added up squared equals hypotenuse squared. Okay. Right, it needs to be in degree mode. Your calculator always in this class, yeah. I know that's difficult because in calculus they want you in radian mode. Yeah, but all of our angles be measured in degrees until we get into rotation, and we'll use radians there. but your calculator will still be in the degree mode because it's only important when you're taking trig functions of angles. Degree mode, always. Okay? But that might be a common mistake that I use. Probably not, but all right, folks. I'm gonna post this online, but I'll have a help session next week too. I appreciate y'all coming out.